So this is really the part that I think most people, when they say they're struggling with this, I don't think it's the inverse and the direct or the joint variation, and I don't think it's the really basic graphing we did in A2. It's usually this one. So here's what you do. You start on the bottom. You do your factoring, then you go ahead and find, is anything going to cancel out? If it's not, it's a whole. If it doesn't, I'm sorry, I should say if it is, it's a whole. If it doesn't, then you find your vertical asymptotes. Then say to yourself, okay, where else isn't this going to go? Because that's what asymptotes are, not where it's going to go. Well, I can also have a horizontal asymptote. And that's when you go up and you check the powers and you say, okay, well, the degree of that one is 0. And, oh, come on, let me back out of there. There. The degree of the top one is 0, the degree of the bottom is 2. Well, then you have to memorize the little chart. So the degree of the top is less than the degree of the bottom, it's 5 equals 0. And you write that down. Then start thinking, okay, now where is stuff going to go? You know, I'd like to have some points without having to use the graphing calculator to find out where this stuff is going to be. That all slid. Everything. So that's when you do the x-intercept, and the x-intercept is the top of the fraction, which you haven't done yet. And again, this one just has a 5. There's no x. There's no way for us to make it a 0, so we're going to write none for x-intercepts. Y-intercepts, wherever you see an x, it's going to be 0. And there it is. So we've got our one little point graph, but we also have our fabulous look at asymptotes. And then we grab the graphing calculator, and I clear out all the stuff I was doing with the other class, and put in 5 divided by parentheses, x squared plus 3x minus 4. Thank you. And zoom 6. And it looks like it matches that, but again, it's a test. We're going to want some table points. So second graph, and let's see it, -5 and -6. We've got a couple of numbers there, not nice ones, but a couple of numbers. So about 0.36, and for -5, 0.83. Get them on there. So at 1, 2, 3, 4, -5, we're going up not quite 1, but at -6, even lower than that. Bless you. Now, on the test, make sure it doesn't look like you cross the asymptotes unless your graph actually crosses. This doesn't look like it's going to make it there, but let me go up in my table and see. It's getting smaller and smaller, but it's never crossing. So I don't want that to cross. Now I need those middle numbers of -1, -2, and -3. So -1 is -0.83. So is -2. And then -3 is -1.25. I already have that y-intercept of 0, -1 and a quarter there. So at -6, I'm sorry, -3, there it is, -1.25. -2, -0.83, same thing at -1, and yeah, we start to see the top of that parabolic piece that was in the middle when we do that. And again, it should look like it's coming close to the asymptotes, but it's not going to cross them. Then we need that stuff beyond 1. So 2 and 3. 2 is, there's that 0.83 again. And 3, 0.36 again. So you can see the symmetry. The numbers are showing up again. So 2, 0.83, +3, 0.36. So that one is going to be really, really close to the x-axis there. And then you'll be done. Not that that's not enough, but you know that's what you need to do. Focus on the denominator first. Get everything you can get from the denominator. All the spots it's not going to go. Then go to the top. See if you can find anything that is on the graph. And after that, put everything you know on the graph before you grab the graphing calculator. Now, how do you know that your asymptotes are right? Tell me how you know that by looking at the table. There it is. Exactly. So this would be a good point when you punch it in to go, oh, yes, thank goodness, I got the asymptotes right. You know, I can see those arrows are in the right spot there. So that would be really good for me. Now, that said, was just the practice quiz. So what we're going to do next is I'm going to start on the practice test. Let's see if that'll come up while I'm handing this out. Sometimes it doesn't like it when I don't use the mouse. There it is. A little bigger. Write a function that models each variation. If x is -5 when y equals 3 and y varies inversely as x. So what does that mean? Divide k over x? Yep, that's inverse. So how do we get k? Plug them in. Okay, so we got a 3 for y, and we've got a -5 for x. So how do we get k? Now, if k is -15, what do? Are we done?
No. Yeah, right. No.
We do.
Yeah.
We absolutely do, and that's usually the step people forget. You know, they find k and they go, yes, I found k. But it said, write a function that models this. We have to model inverse variation. We can't just tell them what k is. We have to show the division. All right, let's see. Number 2 says, x equals 3 and y equals 5 when z equals 6. Oh, we've got more. Y varies directly with x. What does that mean? Multiplication. Y varies directly with x, inversely with z. Divide by z. So we've got more to keep track of in this one, right? How do we get k? Plug in the numbers. Well, 3 over 6 is a half. So how do we get k? Multiply by 2. Done? No. What do? Plug it in. Yeah, go back to the very first equation you had. Y equals 10x over z. There we go. So what's the only one you do division for? That's it. Inverse. Inverse is it. Everything else is multiply. All right, this looks familiar. The table stuff. So it says, is the relationship between the variables, is it direct variation, is it inverse variation, or maybe it's neither one, you know? How are we supposed to know? Remind me, how do we know? We use the eeny, meeny, miny, mo method? Remember, we have to get x and y together on one side of the formula to see how do these two relate to each other from the table, because the x's and y's are what we have in the table. So for this one, we would actually divide both sides by x, and that means if we take the y's and divide them by the x and get the same thing every time, it's actually direct variation. And here we'd have to multiply both sides by x. And that means if we take the table and we multiply them all together and we get the same thing every time, then we have inverse variation. So here's what we need to remember. Direct is multiplication. So to find it, we have to use division. Inverse is division. So to find it, we have to use multiplication. So let's see. Oh, notice the pattern. Do you see anything in table 3 that would be helpful? They are. If you take 14 and divide it by 7, you get 2. 20 divided by 10, 2. 28 divided by 14, 2. So here's what we just did. Y divided by x equals 2. So that one, we use division. That means the itself uses multiplications, which is direct. And what would the equation be for? You plug in a 2 into direct variation. Why is it 2? What's the question? 14 divided by 7 is 2. 20 divided by 10 is 2. We're doing, remember this is a step before. We know that direct is multiplication and inverse is division. But we're backing up and we're looking at the data. So we have to say, what would the step backwards be? Well, if direct is multiplying, the backward step would be dividing. And inverse is dividing, that means we have to look at multiplication to back it up. Because this would be the step that would come before direct. Alrighty. Anybody seeing a pattern yet for 4? Do you get 56 every time? -7 and -8 is 56. 56. 4 and 14, that one took a little while, right? Because it's like, wait a minute, is that 56?
Yeah.
It is 56. So, what type of variation is this? It is inverse. How do we write?
X, Y.
Y equals 56 over X. And that's because that is the standard form of an inverse variation problem. It's not that Brett was wrong. XY equals 56. It'll work, but it won't get you full points because we want to know that you know that the inverse variation problems are supposed to be written as Y equals K over X. That's what they're supposed to be written as. Alrighty, so the variation. 43210, Mian, how you feel about this part of the test?
That's great.
So it looks like you're hoping for a little more practice. Isn't the tables? Are we a little rusty on the tables?
Yeah.
We were really good at it the day we did it. We're a little rusty. All right. So that would be 8-1. Now we're talking 8-2. So we have another little piece of memorization for 8-2. Do you remember the formula for hyperbolas that has the H and K in it? Y equals A over X minus H plus K. Now, this problem just says, what is the domain of the following function? I'm going to give you a hint. There's one number we can't use. What is it? 3. Why is it 3? Can't divide by 0. So the domain can be absolutely anything but 3, because that is a vertical asymptote. That's our H value here. That is a vertical asymptote. Now, this one we did yesterday, and you thought it was a piece of cake, so let's see if you remember it. It says, write an equation for the translation of y equals 2 over x, but moved. So now this is your vertical asymptote, and this is your horizontal asymptote. Both of these problems use this formula right here. So how do you start? A 2 on the top. As they said, write an equation for the translation of 2 over x. Brad, pay attention.
Is it -7 minus 2? Or is it 7? What?
Okay, I'm not saying start talking right away. I'm saying pay attention first. And then.
That was the question I had before I was in the
What's going to go down here? It sure is. And that's because this is a -7, and that's going to make this a 0. So we put that in there. Okay, now what else? +3. Set. Now. Oh, we better do at least one of these graphs today, huh? And then we'll keep the rest of them to keep them fresh in your mind. How do you feel about this one? That was 8-2, by the way. That's all we're going to have from 8-2 on the test. 4, 3, 2, 1, 0. Okay, so some of you right now, it looks like have to say to yourself, okay, I got to memorize that little formula. Y equals A over X minus H plus. Okay. All right. Let's look at 7. You ready? Leads us through. It says, find any holes, horizontal, or vertical asymptotes of the rational function. So look at number 7. Is anything going to cancel out? Is it already factored, first of all, I should say. Is it factored? It's factored. Anything canceling?
No.
We don't get any holes. Not going to happen. Nothing's going to cancel. Vertical asymptote. We have one. What is it? X equals 4. Don't forget the x equals. X equals 4. That's a vertical asymptote. How do we find out about horizontal asymptotes? How do we check? What do we check for horizontal asymptotes? Powers. What do we do when they're the same? Funky fraction. Fraction. Let's do one more of these. Look at number 8. Is that factored? No. No. What could you take out of the top? A 4 and an X. Is that it? That bottom thing looks wrong, doesn't it? Yeah. So how do we flip it? It's not the same thing. A -1 divided by a -1. Pull it out. Exactly. Pull out a -1, and then you have the x in front. Because remember, if you multiply this back, this is going to say -x plus 2, which we could write this minus that. Exactly. We have a hole. Where's the hole? 2. Now, if we wanted to, we want to know exactly where the hole is going to be. We could cancel these out and put the 2 in there. What would you get? -8, yeah. So if you wanted to, this is just, I'm not going to, if you write x equals 2, you're done. You know? But if you wanted, if we had to graph this one, that way we would know exactly where the hole is going to be. All right, vertical asymptotes. We already said that was a hole. Could it be a hole and an asymptote? So do we get any? None. We don't have anything left in the denominator to give us a vertical asymptote. Horizontal asymptotes. That's the degree thing. Top is bigger than the bottom. We don't get any. Remember, if the top is less than the bottom, it's y equals 0. If the top and the bottom equal each other, funky fraction. Top is bigger than the bottom, don't get one. There it is. So that's not everything from 8-3, but I do want to save a little bit for tomorrow. So just on these type of problems where you're supposed to tell me holes and asymptotes, 4, 3, 2, 1, 0. Yeah, I think some people are going to want to work on that memorization of the powers. Yep, little lower numbers there. All right, so tomorrow we will do another one of these, and then we'll go ahead and do the graph it all the way problems. So get a good start on it. You definitely are doing really well with the inverse and direct variation. But lock it in by doing this assignment right now.